Hello students and welcome back to Mechanical Engineering Practice and Graphics. This week we're going to be covering the chapter 9 of the book, Editing Features. Um, First of all, I would like to go back to the schedule. Uh, for this week, we're going to have the homework number 7 due by midnight of Sunday. Also, we're going to have the quiz number 3 on Thursday, and you will be submitting the second part for your final project. Please remember to submit the PDF and the SolidWorks part file. Now, some of you have been submitting the same part, like several members in the group have been submitting the same part. Remember that each of these 5 parts must be different for all the members in the group. So, for example, in the part 1, I can do a window, for example, and then another member in the group can do a wheel, another member can do a chair, and so on. So, if we are 25 members in the same group, there must be 25 different parts in the group. This doesn't mean that all of you should be submitting the same part every week. This means that all of you should be submitting different parts every week. Okay, and also remember that the parts must be uh, at least 2 or 3 features. So it's not enough to do very simple geometry, just an extrusion, and that's it. No, I'm requesting a little bit more of a little bit more effort from you on these 5 parts. It's only 5 parts for your final project, and then putting everything together. So just try a little bit harder. So again, this week we have homework, quiz on Thursday, and the second part. And remember that next week we're gonna have the second midterm. Um, but we're not gonna have homework next week. So you will have some more time for doing the midterm exam. Okay, so for this week I'm gonna do 2 tutorials. I'm gonna show you here how to do ribs and how to understand this kind of dimensions that I'm showing here. This is the first tutorial. This is not graded. The second tutorial is gonna be this one. Again, here we have a this dimension that you haven't seen before. And the homework for this Sunday is gonna be this one. So at the end of the class today, I'm gonna give you some tips on how to do this homework or some considerations that you must keep in mind when doing this homework. Okay, so let's begin. I'm gonna start by creating a new part. And then from this blueprint, um, what we have here is that here I have an isometric view, also an isometric view from the back side or the lower side of this geometry. Here we have 6 ribs as we see in the isometric view, several geometries that are repeating themselves in a circular pattern. Also, we have 2 section views. The first one is the section AA that goes through this discontinuous line and then upwards. And that's what we're seeing here in section AA. But also we have the section BB that is going in this horizontal line for construction and then upwards. And then we see that section view here below. So I'm gonna start by using the section BB in the front view, and I'm gonna have my origin in the center of the figure and in the lowest point of the figure. So using the front plane, I'm gonna start creating a new sketch. As usual, I start by adding lines for construction in the origin, one horizontal and one vertical line. And then I'm gonna do this geometry that we have here in the section B. So something like this. something like this. It doesn't have to be perfect, just trying to follow the same trend. And then I'm gonna start by adding some dimensions there. So the first thing that I'm gonna do is I'm going to add this diameter from this inner hole by using the Smart Dimension tool. I first click the axis of revolution and then the inner side of that hole. And then here I'm gonna put 10 millimeters. And then we have the outer side of this cylindrical shape here. It's 20 millimeters, so I'm gonna add that. Also, here we have this height, which is only 2 millimeters. Then here in the top view, we have the outer diameter of this shape, which is 42 millimeters. Then we also have um, the where this geometry is going up, this side here, is this other diameter. Here we have 40 millimeters. So I'm gonna add that. I forgot to put here this thickness or the height in this section BB, which is 3 millimeters. So I'm gonna do that just by selecting this line. Also, I have this other height, which is 11. Then we have this inner diameter of the inner wall, which is 34. So we can add that. Finally, as we see here in this section view, these two lines are collinear, so I can define that here between this line and this other line. They both are collinear. Then we have this other diameter, which is 12. And also we have this height here, which is only 1 millimeter. That's it. Our geometry is fully defined, so I can exit this sketch and then create a revolution for this geometry using as axis of revolution this center line. Then I click OK, and we have our initial geometry there. Now what I'm gonna do is I'm gonna do a section for this. So I'm gonna use the front plane to create that section. I select the front plane and then I go here in the top where it says section view, the fourth icon from the left. Then I click OK, so I can see that section. Using that same plane, the front plane, I'm gonna create a new sketch. Control 8 in my keyboard. And then I just draw a line from this corner here, this corner, to this second corner. I'm gonna just draw a line from those 2 points. And that's it. Now I'm gonna exit this sketch. I'm gonna rotate it, and now we're gonna learn how to use the rip option. Um, this is just to create a stiffener for that geometry. In this case, our rip is 2 millimeters in thickness. So as you see, I can define either only to one direction or to the other direction or center. In this case, it's only 2 millimeters. And this little arrow is showing me where it's gonna fill material. So if I flip it, it should just add material in that direction. But in this case, I want it to go downwards. So that's why it's selecting this side. Or I can just flip it to the other direction as well. Okay, I'm gonna click OK in this case. I'm gonna deactivate the section view. And we see now how that rib is created. Then I'm gonna create a circular pattern for that rib. I have to select the rib. And then in the center, I can select any circle. It will recognize that the center of the circle is the center of revolution for that pattern. So I'm gonna use the equal spacing in an entire revolution, but this time it's gonna be an amount or a number of instances equal to 6. And then I click OK. There we have those 6 ribs over there. Now what I'm gonna do is I'm gonna use this face here to create a new sketch. And here I'm gonna start by adding a vertical line for construction that goes through the origin. And also I'm gonna use the convert entities tool to create a circle here. Then okay. Now this circle is gonna be only for construction. That's okay. And then up here, I'm gonna start by doing several circles. And then I'm gonna add a line that is coming from the circle in the other part or the biggest circle all the way down to this circle for construction. Now these two should be tangent, so I'm gonna add that. And now I'm gonna add those dimensions there. So what I'm doing here is I'm doing this geometry here with these holes in it. Now, as you see in the section A here, this line here, we have that the small cylinder is going all the way. The material is a circular hole, but then there is a bigger hole in diameter that goes only halfway through, and that's this dimension that we have here. This is saying that we have 3 holes with diameter equal to 3.6, and each of these 3 holes has a partial hole with diameter equal to 6.7 millimeters that is going inside the material only 1.65 millimeters. So I'm gonna start by defining the smaller circle there, 3.6. Then the second one, which is 6.7. And then the largest circle is actually this arc that we have here, that is radius equal 5. This one is actually 12. And then we have also the distance from this center to this center, which is given by this circle for construction here. As we see here, we have the radius equal to 25. So I can just define that distance there. And then I can mirror this entity to the other side of this line for construction and close this using a 3-point arc like that. Now I'm gonna delete what I don't need. So for this case, I don't need this part of the circle, neither this part or this part. I'm just making sure that we don't have any remaining from the previous circle. And also I would just like to make sure that these two lines are tangent. Again, this geometry is fully defined. I can now uh, exit this sketch. And then I'm gonna create an extrusion of this sketch. For the contour, I'm gonna clear this selection. I'm gonna select this part here and also this other loop to the other side. And I'm gonna select up to next or up to vertex. No. Yes, up to this vertex. Sorry, up to surface and this surface. Because as we see here, it has the same height as the outer surface here. So I'm just making sure that that happens. Or I can also define just the dimension here, which is 3 millimeters. So we have that extrusion there. And also using the same sketch, I'm gonna create a cut using this part. Now this one is gonna be, as we said before, only 1.65 millimeters inside the material. And that's it. Now I can select these two operations, either using Control or Shift in the keyboard. And then I'm gonna use a circular pattern. As you see, I have those two operations here. And then the center is gonna be the center of this circle. Now for this circular pattern, I'm gonna use only 3 repetitions, 3 instances. And then okay. And that's it. That's how we have this geometry. So remember, the first thing that we did was just a revolution of this sketch here. Then we add the rip and did a pattern for that rip. Then we created the one single geometry in this part, and then we add the pattern for that geometry. And that's how you create this shape. And now we can continue to the next tutorial. Okay, for this second tutorial, you will see that we have a couple of holes going through the material here and also here. Also 4 cylindrical holes in this part. And again, we have the same dimension as before. This means that we have 2 holes with diameter equal 15 going inside of the material 25 millimeters. Now, as you see here, I'm gonna just zoom in into the slide. These cylinders has this angle shaped here in the revolution. Usually this angle is 30 degrees from the horizontal. So I'm gonna show you how to do that as well. Let's begin. Okay, using the front plane, I'm gonna start by adding just lines for construction, 2 of them. Actually, this line, I don't need this line. And then I'm gonna create only this geometry here, but only up to this part. Then I'm gonna close it. And so I'm gonna create just this geometry here. Then I'm gonna define this diameter here, which is 48 up to this point. Then we have this 84 up to this point. And then we have 42 for the height. And 15 in this thickness. Also, here we have this maximum diameter, which is given by this 171. There it goes. So I exit the sketch. Now I'm gonna do a revolution using for the axis of revolution this center line, and then okay. Now using this top surface here, I'm gonna create a new sketch. Control 8. For this one, all I'm gonna do is I'm gonna draw a circle here and then another circle like here. It's actually smaller. This one and this one are horizontal, and this one is the diameter of this one is this outer part, so the radius is 31. So 31 times 2 is 62. And then this other one here should be radius equals 16. So this one is 32. And then the distance from the center of this circle and the center of this circle is actually the distance from these two should be actually 1/2 of this. As we see, these circles here are these cylindrical shapes here, which are 75 millimeters apart. So I can define that dimension there. This one is 75 divided by 2. And then I can add line here and here. It is already tangent. And then I'm gonna, well, I should have started with this. Just adding the lines for construction here and here. And that's because I want to mirror this line using this mirror, and then mirror again all of this using the vertical line for construction. I can use the trim entities to delete everything that I don't need, like this. Then I click OK, and I can create now that extrusion over there, which is 75 millimeters. Okay, again, I'm gonna use the section view using the front plane so I can see inside the material. To activate this, I just select the front plane, then I click in section view, and then here in OK. And using that front plane, I'm gonna create a new sketch. So the first thing is I'm gonna create the axis of revolution. And for this one, I'm gonna start by doing this geometry here. Now you may be wondering why I am doing these lines beyond uh, the dark gray area. It really doesn't matter. I can just move this line and make it coincident to this other line, but I'm just gonna show you that since I'm gonna just do a hole inside this material, it really doesn't matter if I don't have any material here. So having that in mind, I'm gonna start by defining this diameter in the bottom, which is 27. Then we have that the big diameter here is actually 39, and these two lines are collinear. So this one here is 39, and these two lines are collinear. Finally, I have that the small diameter here is only 21 millimeters. Now I'm gonna define this vertical distance here, 30 millimeters, from this bottom part to this part, 30 millimeters. Then we have 12 here and 24. This one is 12, and this one is 24. And that's it. Sorry. Uh, Even when, as I said, this is not fully defined because I'm not defining the vertical position of these two lines. Everything inside is actually defined, so I'm gonna just leave it that way. Now I can exit this sketch and create a revolution to create a cut like that. This preview is showing me where it's gonna cut the material. Then I'm gonna click OK, and that's our hole inside the material. So if I deactivate the section view, we here in the top we're gonna see only like two circles, even when there is another one inside that we can only see using the section view. Now using again the front plane, I'm gonna create a new extrusion, sorry, a new revolution. This one is gonna be not in the center, it's gonna be actually over here. We have seen this before. This distance is 75 divided by 2, which is this 75 divided by 2. And then here I'm gonna create something like this. Now we have that this angle here is 30 degrees. We have that diameter there, which is two holes with diameter 15. So this diameter here is 15. And also here we have that the depth is 25, and that depth is measured actually from here, from this edge. So from this edge to the surface, here we have 25. I can exit this sketch now, create a revolution, and then I can create a mirror for this revolution using the right plane. And then we have the second cut at the other side. Then in this phase, I'm gonna create another sketch. In this one, I'm gonna create a horizontal line for construction. And then I'm gonna create another one here that is at 45 degrees. Then I'm gonna do a circle for construction here. It's for construction. This circle for construction has a diameter of 126 millimeters. And then a circle here. This circle is diameter 15. And then I'm gonna do a circular pattern using this center for the circle. This time is only a pattern of 4. That's perfect. And then I extrude cut those holes up to next, and then okay. Finally, I finish with a fillet with radius equal 5 in this edge. And that's it. That's our finished geometry. Remember that if you want to see the section view, you can use this button here, this control. Also, we can change the how we are viewing this. I can also see the hidden lines inside to see those holes inside the geometry. And that's it. Okay, so the tips for the homework are as follows. Well, now you are familiar with this icon. This means that the this small hole, this horizontal cylindrical hole here, has a diameter of 10, and it's going inside the material only 10 millimeters. Pay attention to this section view. As you see, these two cylindrical holes are not connected. And also, if you zoom in into this figure, you will see that this extrusion has no gap here with this cylindrical extrusion. Also that you can create this slope here using a rip or any other method that you prefer. You can also do just a normal extrusion. Also here we have this icon or this dimension that you already learned today. This means that the smaller hole in diameter is 24 and goes all the way as we see here in this section. But then the bigger hole that is with diameter equal 30 goes only 8 millimeters inside the material. So that means that this height here is 8 millimeters. Uh, those are the few tips that I can give to you in this homework. Um, and that's it for this class. So remember that this week we have the homework number 7. We have the quiz number 3 on Thursday. I'm gonna post it at first minute of the day, and you will have until midnight as usual. And then you will be submitting the second part for your project this weekend. Um, Please keep in mind that you're gonna be putting all of these parts together within an assembly, so all the parts must fit together. So communicate with your with the people in your group. Uh, all these uh, dimensions that you are considering for your parts. Otherwise, you will have to modify everything again when you are going to put everything together in the assembly. That's it for this class. Thank you very much for watching the video and see you next week.